very pleased to finally be here in the District of Columbia. I'm also very pleased to be able to say that we're not here because this technology is green. We're not here because it's the technology of tomorrow. We're not trying to convince you of some odd wonders of technology. We're here because this technology on display works. It's reliable, it's affordable, and it should be in our buildings right now.
We are very fortunate here. You may have heard about Sustainable DC, which is a major initiative of Mayor Vincent Gray. And so we look at all of the urban sustainability issues that we feel are very important for us to focus on now that more than 50% of the world's population lives in urban environments.
We came up with the smallest set of measures that you could take in a home with the biggest impact on the net results. And this is the home energy score that came out of that. It's really to drive those folks that wouldn't have otherwise done some sort of evaluation. It tells you where your home performs, where it could perform, how it performs in relation to others in your either neighborhood or similar type homes, and then some examples of areas you can focus on.
This kind of a discussion of renewable energy, energy efficient design in the public discourse is valuable for architects and engineers, having it become an everyday part of discussions, be in forums of all different types, makes our clients more informed, makes our job a little bit easier. And quite frankly, this is an excellent time to be an architect or an engineer focusing on energy efficient design.
One result that is interesting, and we see that in all of our projects all over again, is the real savings in these buildings is if we switch from all air systems to water-based systems. This does 30% of the trip. Right. And these are the results here. We can reduce the heating consumption, energy consumption for heating, and also for cooling. We reduce significantly the energy for fan power. We increase typically the energy that is used for pump power, but it's way more efficient to transport energy with water than with air. That's just physics.
Previously, when people think about fixing their home or fixing their building, they make a decision themselves and say, oh, I know what it is. It's the windows. I'll replace the windows. And you call the window person up and they're very glad. They say, yep, it's the windows. Let's replace them. This is not the way a building works. It works as an integrated system, just like a high-performance automobile. Obviously, quality components is important. In that high-performance automobile, let's say there's 10 parts. There's not more. But let's say there's 10 parts. If 9 of them are absolutely great, top quality stuff, and then you pick the 10th one that's okay, but it's not matched to the other 9, it doesn't matter how good the other 9 are, the whole system is not going to perform very well. And I think everybody can inherently feel that. Houses, buildings work exactly the same way.
It's great when we do changes in residential market, but what we've seen is that we can make bigger changes in the commercial markets. And this is a great example of Capital City Charter School right in our backyard here in Washington, D.C. This is the first charter school to use a triple pane windows, and they're using our products here. Now, the reason why they chose us was not because of energy efficiency. It was not because of the sustainability. We were about $300,000 less expensive than double pane aluminum systems that they were about to use.
Long Island Power used to sell solar panel systems to folks on Long Island, and their built-in assumption for energy inflation was 15%. If you assume that energy rates are going to go up by 15% a year, which is about what they did between 2002 and 2008, almost anything you do to a building makes sense economically if it saves energy. Right? 15% a year, it's going to be quadruple in 20 years by the time your product is all used up.
In this symposium, we will explore some of the thinking, planning, and scholarly work that goes on in promoting, exploring, and applying the net zero idea.
Policies need to consider the total energy consumption of buildings. Think about the whole building concept. In this country, we've tended to focus on components on building blocks. We've done a lot of great stuff with our energy codes, for example, in making chillers, air conditioning systems more efficient. The envelopes have gotten more efficient, looking at the glazing and things like that. So if you look at individual components that are addressed in our codes today, they have certainly gotten significantly better. However, when you look at the entire building, there are many loads, all the plug loads, all the computers, things like that, that aren't being addressed. And as a result, we certainly have flattened the curve to a large degree, so we're not increasing the rate of growth as much, but we're not truly bringing down the energy consumption of buildings at the rate that it needs to be brought down.
And I don't know who works in office buildings, but most of the women I work with wear sweaters in the summer and have heaters as well in the summer because it's too cold. And part of the reason is because men wear coats inside because we decided that suits are formal attire. And so these are actually the sorts of things that we have to start talking about is, does everybody need to wear a suit that was designed for cold weather in Europe in the winter, in the middle of the summer when it's hot?
3% of the water on the Earth's surface is fresh, 1% of that is potable. The average American uses somewhere, depending on what you read, between 120 and 160 gallons of water per day. Some places in the world, people exist on somewhere between 3 and 30 gallons of water per day. We can do better, and we have to do better. And some of the places where codes are failing us or are not yet keeping up with us is in terms of the care and stewardship of water.
The design of our pavilion is slightly different. It is not a full house per se, as the solar decathlon houses are, with bathrooms and showers and bedrooms and everything. Ours is really just an exhibition space. So it's about 10 meters by 10 meters, about 33 by 33 feet. And it's built to travel.